Guys, another example in chapter 12. Chapter 6, number 10. Let's pick up the problem. And this involves confidence intervals. Find and interpret a 90% confidence interval for the mean years of service and proportion of employees. Okay, so let's go through this step by step. Let's look at the data. Again, I believe this is easier, at least for me, it's easier in StatCrunch. We open up in StatCrunch. And we have mean years of service. So let's do the first one first. So we'll say stat. Now, let me go further. Before I do that, I should point out that there are two types of general categories of hypothesis testing and confidence intervals. One involves the Z, one involves the T. The Z is used when you know the population standard deviation, which is very rare and almost unrealistic, but it is used. The T is used when you estimate the average from the sample, but you also estimate the standard deviation that you need as part of the formula from the sample. In other words, how much variability is there in the data? In this particular case, let's read it carefully. Okay, they're using just the regular data, so we're going to go to the T. So we go to T, dealing with one sample, and this time we have the data. We want years of service as the variable. We want confidence interval. We want 90%, I believe. And then we hit compute. And the number is 11.11. Copy. Control V. Up to, whoa, where are we? To 17.38. Check answer. And so far, so good. Interpret the confidence interval. Choose the correct answer. Okay. What does it mean to be 90% confident that the population average is somewhere between 11 and 17? Again, think about it. We just got an average of, I guess it's going to be on the printout. The actual average was 14.25. That was the actual average of the sample of 20 people. All right. So but that's just a sample of 20 people. You took another 20 people, you're definitely going to get a different answer because 20 different numbers might come out to 14.88 or 13.76. So now we know the real answer, the real population is probably somewhere between 11.11 and 17.38. So let's see what the possibilities are. No. I like B so far. This is not true because the sample mean has to be between these two because the formula takes you the mean and you add something to it and you subtract something from it. No, that's not going to work. Okay, the answer is B. We're 90% confident, which is like a probability. It really means that if you repeat this process 100 times, and each time you get a different average and therefore a different interval, 90 out of 100, 9 out of 10 will cover the unknown average. So we're 90% confident the population mean is somewhere between these two numbers. Anyway, I'm pretty sure this is right. And again, a deeper understanding, you would peruse the videos that I made about confidence intervals and the interpretation. Now they want to do the same thing. Instead of dealing with averages, they want you to deal with proportions. Okay, we'll do the same thing. Probably be very similar. You go to StatCrunch, we eliminate this, go to stat, proportion stats, one sample with data, because we have the data. The graduate degree, yes or no, is the variable. I guess we'll define success as a Y. I'm not sure this is going to be right. We want a confidence interval of 90%. Compute. And it was right. That you put a Y in there because Y was the symbol for the success in this case. So there were 8 out of 20, which is 40%, and the lower limit is 0.219 or 21.9%. The upper limit is as high as 58%, and the reason why it's so wide is because we have a relatively small sample. So even though the average was 40%, it could be anywhere between 21% to 58%. Wow, pretty big spread. Check answer. Good. Interpret. Well, it's the same as before, except now for population proportion. So it's going to be part A, but let's look at the other choices. No. 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 We're done. Okay. If you enjoyed that, stop sharing. X out.